Hello students, so today we are going to study work energy theorem. So we know that F is equals to ma and dw is equals to F dot ds. Therefore dw is equals to ma ds. Now the total work done by all the forces acting is work done total is equals to integration of dw is equals to integration of ma ds. Now m, because of being constant, comes out of integration, and ads we already know from kinematics is vdv. Therefore w is equals to m integration of vdv from v initial to v final. Therefore work done is equal to half mv final square minus half mv initial square. That is, work done is equal to kinetic energy final minus kinetic energy initial. Therefore, what we can state that the sum of work done by all the forces acting on the particle or on a system is equal to the sum of the change in kinetic energy of each particle of the system. This is what we call work energy theorem, which signifies that work and energy are transferable or work and energy are interconvertible. Now we must keep in mind that work energy theorem can be applied for all sorts of forces. And if all sorts of forces are acting on the body, like external forces, internal forces, pseudo forces, or other types of forces, then work done by external force plus work done by internal force plus work done by pseudo force plus work done by other force is equals to change in kinetic energy of the system. And if sum of all the work done is positive, then the kinetic energy increases, and if sum of all the work done is negative, then kinetic energy decreases. This particular theorem helps us solve numericals which are otherwise very difficult to solve via kinematics. Okay, so let us have a bowl and a ball which is resting at the top of the bowl. Like, suppose I am telling you there is a small ball which is placed at the top of a smooth spherical bowl of radius r, and if now the ball is accelerated with an acceleration a, our aim is to determine the velocity of the ball with respect to the ball as a function of angle theta with respect to vertical. So as the ball accelerates towards left, what are the forces that are acting on the ball if observed from non-inertial frame? So one force is pseudo force, the another force is gravity, and then there is normal reaction acting. Work done by normal reaction we know will be zero, because normal reaction will always be perpendicular to the path. And suppose the ball in its new position is at an angle theta with respect to vertical, so it has come down by a distance y, where y is equals to r1 minus cos theta, and it has moved towards right with respect to a non-inertial observer placed on the bowl by a distance r sine theta. So work done by pseudo force is m into a into r sine theta, and work done by gravity is mg into r1 minus cos theta. So ma r sine theta plus mg r1 minus cos theta must be equal to change in kinetic energy of the body, that is half mv square. So we get v as under root of 2 gr 1 minus cos theta plus ar sine theta, and this particular v would have been otherwise now very difficult to calculate via kinematics, which we easily determined by work energy theorem.